Today's lesson is on the applications of linear systems, which basically means lots of story problems, creating linear equations from a story problem, applying it to a real-world scenario, and then solving the system, and then trying to figure out what your solution actually means in the scenario. Suppose you are starting an office cleaning service. You have spent $315 on equipment, and to clean an office you use $4 worth of supplies. You charge $25 per office. How many offices must you clean to break even? So breaking even is a common scenario with linear systems because you're looking at how much money you spend versus how much money you make. And when the amount that you spend equals the amount that you make, that is referring to breaking even. So you always break even before you actually start to make a profit. So we're going to write two equations, one that has to do with how much money you're spending and one that has to do with how much money you're making. So it said that you had to spend $315 on equipment. So there was that initial $315, but you also, every time you clean an office, you're going to spend $4. So $4 per office that you clean, plus you had to spend $315 at the beginning. And then, how much money do you make? When you clean an office, you charge $25 per office. $25 per office. So now, we've got two equations in slope-intercept form. To solve them, we can use substitution, where we set one equation equal to the other. So, when is 4x plus 315 going to be equal to 25x? Where x is represents the number of offices. So first, let's get our variables onto one side. Subtract 4x and subtract 4x. So 315 equals 21x. And then divide both sides by 21. And you should get that x equals 15. And that represents offices. When you clean 15 offices, you will break even, and then any more that you clean after 15, you'll actually start making a profit. And in this case, because they're just asking how many offices, we only need to solve for x. You don't need to plug back in to solve for y. Alright, second question. A light plane flew from its home base to an airport 255 miles away. With a headwind, the trip took 1.7 hours. The return trip with a tailwind took 1.5 hours. So in other words, on the way there, you were going against the wind. On the way back, you were with the wind. Therefore, the time took less. Find the average airspeed of the plane and the average wind speed. So, you can think about the distance equals rate times time. And in this scenario, we can have two different equations where we know the distance, 255 miles, and we know the time, 1.7 hours and 1.5 hours, but we need to find the rate. But they're asking to find two different rates. The average airspeed, so how fast is the plane flying, and then the average wind speed. So what is the wind? So let's think, let's use A for airspeed and W for wind speed. So before I start writing equations, let's just think about this for a second. If you are going with the wind is going to speed you up. So your rate would be whatever your airspeed is plus the wind speed. But if you're going against the wind, you have your airspeed, your wind is going to slow you down. So we're going to use that idea to get our rate for our two equations. So our two equations, one is representing going to and the other one is returning. Both cases, the distance is 255 miles. So 255 equals 255 equals, because the distance is the same. And then we have rate times the time. Well, we know the time. Going to, it was 1.7 hours. So the time is 1.7, and then times the rate. I'm going to come back to that. And then returning, it was 1.5 hours times the rate. All right, so going to, let's see, we had the headwind, we were going against the wind. So the rate is the airspeed, minus the wind speed. And then returning, we had the tailwind, so the wind was speeding us up, so it's the airspeed plus the wind speed. So here we have our two equations rewritten side by side. And what I'm going to do is something a little bit different. It looks like we would want to distribute the 1.5 and the 1.7. But instead, to, in the long run, make our life easier, if you notice, these are both being multiplied. So what I'm going to do is actually divide both sides by, well, first the 1.7. And then on this side, I'm going to divide both sides by 1.5. So 255 divided by 1.7 is 150. So I will be left with the equation 150 equals A minus W. And then 255 divided by 1.5 is 170. And I'm left with A plus W. So these are my two equations, and they're both written in standard form. So I'm going to solve these by elimination. So let's rewrite them so we can use elimination. We have two different choices because the coefficients for our variable a and w both match up. It's just one will eliminate when we add, the other will eliminate when we subtract. I'm going to add these two equations together, so I'm going to eliminate the wind speed. So 150 plus 170 is 320 equals a plus a is 2a. Divide both sides by 2, and we get that a equals 160, and that's airspeed miles per hour. So the plane is traveling at a rate of 160 miles per hour. So now let's find the wind speed. So you can pick either one of those equations. Let's pick this second one. 170 equals 160 plus W. And if you subtract 160, you'll get that W equals 10 miles per hour. So we were able to find the airspeed and the wind speed, 160 and 10. All right, here is our next question. Suppose you bought supplies for a party, 3 rolls of streamers, and 15 party hats. So let's see. Let's do streamers and hats as our variables. We have 3 rolls of streamers plus 15 party hats cost $30. And then later, you went back to the store and bought 2 rolls of streamers and 4 party hats, and this time it costs $11. How much did each roll of streamers cost, and how much did each party hat cost? Well, let's solve this system using elimination. And as of right now, our variables don't match up, so let's multiply our equations by something to get our coefficients to match up. And I'm going to match up variable s, streamers. So I'm going to multiply the top equation by 2 and the bottom equation by 3. And I'll actually let's do -3. So my top equation now turns into 6s plus 30h equals 60. And then the bottom equation will be -6s minus 12h equals -33. So now, because I have a +6 and a -6, I'm going to add these two equations together to cancel out the streamers. So 30 plus -12 is 18h equals 60 plus -33 is 27. And then if we divide both sides by 18, 27 divided by 18 is 1.5, which means the party hats each cost $1.50. But they also want to know how much does a roll of streamers cost. So you can pick any of those 4 equations. I'm just going to pick the very top one. And we're going to plug in $1.50 in for h and solve for s. So 3s plus 15 times 1.5 equals 30. So 3s plus 15 times 1.5 is 22.5 equals 30. Subtract 22.5 on both sides. So 3s equals 7.5. And then divide both sides by 3 so that s equals 2.5. So a roll of streamers is going to cost $2.50. Alright, here's our last example, applying linear systems into story problems into real-world scenarios. Your teacher is giving you a test worth 100 points, containing 40 questions. There are 2-point questions and there are 4-point questions on the test. How many of each type of question are on the test? So there's 2 different kinds of questions. Let's just do X will represent the 2-point questions and Y can represent the 4-point questions. So how many total questions are on the test? There are 40. So if you take all of the 2-point questions plus all of the 4-point questions, there are a total of 40 questions. And then if, let's see, well, the 2-point questions are each 2 points, and then plus the 4-point questions, 4 times the number of 4-point questions there are, you get a total of 100 points. So it's how many questions and then how many points are your 2 different equations. You could solve this by elimination, or to change things up, we could solve this by substitution, because this equation would be really easy to rewrite as y equals -x plus 40. So just to change things up, for those of you that like substitution better than elimination, and if y equals -x plus 40, you can plug that in for y. So let's rewrite this equation. 2x plus 4 times y, which is -x plus 40, equals 100. Distribute the 4. So 2x minus 4x plus 160 equals 100. 2x minus 4x is negative 2x plus 160 equals 100. Subtract 160, so negative 2x equals negative 60. Divide by 2 so that x equals 30. So let's go back and think, well, wait, what does x mean? X represents 2-point questions. So that means there are 30 2-point questions. And if there are 40 questions on the test and 30 of them are 2-point questions, then that means that there are 10 4-point questions. So there are 3 different scenarios, all very, very different, where you can apply linear systems. So, and then with them, you can use elimination or substitution depending on how you set up your equations. So let me know if you have any questions, and good luck with the lesson.